Hey besties, welcome to the video solution for USB versus PS2. So, if you haven't read it, you can pause the video or go on the website and read it. But basically, you have two types of computers. Some computers have USB ports, and then some computers have PS2 ports, and then some have both. And you also have a bunch of mouses as well. Either the mouses are USB or PS2, and then there are also different prices. So you are very poor and you want to minimize the cost of the mouses that you will buy. So there's all this info. Also, let's go down to the input. So there's 3 integers, A, B, C. Wow, the alphabet. So these are how many computers have USB ports, how many computers have PS2 ports, and then the number of computers with both. And then you get another integer, which is the number of mouses you have, and then each mouse has a price, and then also the type. So what we have to do is try to make as many computers as possible have a mouse, while also trying to minimize the cost. Okay, let's turn over to this screen over here. I have the input here. So my first intuition for this problem is that you have to minimize costs, so that you would probably want to decrease or pick the mouse with the smallest cost. So in this case, for PS2, I guess we can start by simplifying the problem down. So we can choose one mouse to care about for now. So either USB or PS2. I guess we can just care about PS2. So PS2, it's B. There's one PS2 mouse. So we've got all these 3 PS2 mouses. They have different values. There's a 6, a 3, and a 7. So given this, if you want to minimize costs, it's pretty intuitive to just pick the one with the smallest cost. And so in this case, if we only need one PS2 mouse, then we would obviously just pick the one that costs 3. So if we simplify the problem to just PS2, then the answer would be 3. However, let's add in another variable. So there's also a USB mouse. So given a USB mouse, we have 2 of USB mouses. So we need 2 of them. However, you can see that there's only one USB mouse here. So that means that one of the computers isn't going to have a mouse, I guess. So we have 5 because that's the value of the USB mouse. And then we want 2 mouses, but we only have 1. So unfortunately, we can only have the value of 5 over here. So what we can learn from these 2 simplified versions of the problem is, number 1, that you want to go for the smaller values. So you want to prioritize cheaper mouses, I guess. And then from the other part of the problem, we can see that not necessarily all computers are going to have mouses. So you have to keep track of the computers with no mouses. So it's not necessarily just pick the 2 largest ones, because in this case there's not another 2. So I guess there's a case where you don't have enough mouses, and you have to care for that too. Okay, so given this is pretty intuitive, but there is another problem. So the third variable is combining both of these. So again, you'd want to pick the cheaper mouses, but since these computers have both, you would need to combine the 2 arrays somehow. So my solution for this would probably be to take all the remaining mouses. So as you can see from here, the 5 has already been used, so we can cross that out. The 3 has already been used, we can cross that out. And the remaining mouses are going to be the 6 and the 7. So after we calculate the first 2 parts, I would probably just make a array, or not an array, some data structure that's sorted, that holds what has both of these elements. So in this case, we have a 6 and a 7 left. So we would just get the 6 and the 7, and then do the same process again. Just pick the smallest one, since there's only one we need, and then we'd pick the 6. So then all in all, we have the 3, the 5, and the 6. And then if you add that together, it goes up to their test case, because there's 3 mouses. There's 1, 2, 3, and then they add up to 14, because that's their cost. So 3 plus 5 plus 6 does equal to 14. And then that's how you get your answer. So I guess to sum up, we need to first sort the mouses based on their identity. So we basically need to sort them based on if they are USB or if they are PS2 and put them in different groups. And then while they're in their respective groups, you have to sort them so that we can figure out which ones are the cheapest out of these. And then after you do all that stuff to calculate the C variable, you combine the USB and PS2 mouses that are remaining, and then you try to figure out the smallest ones out of those. Cool. So in order to solve this, I coded in Java, by the way. There is one special data structure we can use. There's a lot of ways to solve this problem, but personally, I use something called a priority queue. So what a priority queue does, let me write it, sorry. Oh my God, it's so thick. Okay, what a priority queue does is that it takes in like all your elements. So if you have like, you can input like 3, 7, 2, 4 or something, and it will sort them for you, and then it will output the first one, the smallest number, I guess. So if you input all these elements, it'll go 2, 3, 4, 7, and then if you do a function called poll, it looks like this, then it'll take the smallest value in here. So in this case, given this queue, it will be able to give us the smallest number within a group, which is exactly what we need. So yeah, let's turn to the code. Okay, so here's my code. I wrote it in Eclipse. So basically, the beginning is pretty easy. You just make your scanner and then take in your input. And then here are our priority queues. So for now, we will need 2. The first one is going to store all the USBs, and the second one is going to store all the PS2s. And then we will take in the input. So again, that would just be like a number, which is the cost, and then the identity. So that's what we're doing here. We're sorting them into their respective priority queues. Cool. And then after, we can do our calculations. So again, when we looked at the test case, there's 2 things you need to keep track of. The first one is that there's not necessarily going to be enough mouses to keep track of every computer. So that's what this part is. And then also, this is our poll function again from the priority queue. And then once you get that number, you add it into the sum, which you add it into the total, which keeps how much you have to spend. And then you also keep a sum, which shows how many mouses there are. And then you'll do that for both of the USB and the PS2. And then what's super cool is that you add all the remaining things together within one of the arrays. It doesn't matter which one, or one of the queues. It doesn't matter which one, but I picked USB. I just it was first. So you put all the remaining USB mouses and PS2 mouses together. And then you're able to do your final calculation with this final queue, and then you will be able to output your answer. And then, yay, that's the whole code. Thanks for watching.